Okay, so I wanted to talk about for each of the following functions here, going over the class notes for today, how to find the equation of a tangent line to the graph of the function at the given point. I'm going to go over a couple of these problems just to reiterate what I did in class today. So I'm going to go over the last two here. If I look at this function here, g of theta equals to 2 theta plus 3 cosine theta when theta equals pi. So first thing I need to do is take the derivative. So g prime of theta will give me 2 minus 3 sine theta. Again, treat theta like it was x. Okay, so if I take the derivative of 2 theta, this would just be 2. So it would be the same thing if I took a derivative of 2x, I would just have 2. Okay. The next thing I need to do is evaluate g prime of theta at pi. So g prime of pi gives me 2 minus 3 sine of pi. I'm going to write it in black so you can see the differentiation of what or differentiating what I'm doing here. So g prime at pi will simply yield me 2, since this guy goes to 0 evaluated at pi. So that's my slope. So I'm 2/3 of the way there. When I look at the line of a tangent line here, I do y minus y1 equals to the slope m times x minus x1. Again, this is what we remember from Algebra 1. I need to find y1. So y1 is equal to g of pi, which will give me 2 times pi plus 3 cosine of pi. So y1 will equal to 2 pi minus 3, since cosine of pi is evaluated as -1 as a result. So therefore, I have my y1, I have my slope m right here, and I have my theta equal to pi, so that's basically my x1 value. So my line is y minus 2 pi minus 3 equal to 2 times x minus pi. And that is my line right there. I don't have to go any further because the equation of a line can either be in intercept form or, in this case, point slope form. Moving on to this function. First thing I need to do is rewrite this as h of x equals to 2x over, I take the square root and turn it into an exponent. That's going to give me x to the 3/2 power. So h of x simplified will give me 2 over x to the 1/2. Remember that this is really saying 2x to the 1 power minus 3/2. So I'm going to get a -1/2 as an exponent, and therefore I'm rewriting it as 2 over x to the 1/2. But then again, to do the power rule, I have to turn this into a polynomial form, so I have to write it as 2x to the -1/2. So I should have written it that way. Now in fourth period, I'm sorry I made a mistake somewhere. What I did, I feel like I did something else doing the math, so I apologize. That's why these notes are going to be very helpful when you see it. So if I take the derivative of h now, h prime, this will give me 2 times -1/2 times x to the negative 3/2 now, because I have to subtract 1 from the original exponent. This will give me a slope function of negative x to the 3/2. Now, evaluate it at x equal to 2. So h prime of 2 is going to equal to negative 2 raised to negative 3/2. We don't know how to do that, but we certainly can rewrite it this way. Negative 1 over 2 to the 3/2. Simplifying this further, this is really saying negative 1 over the square root of 8. And I can keep it that way. I don't have to go any further from this here. So here I have my slope of the function, and I have my x point, which is up here, x equal to 2. So all I have to do right now is find out what is my y1. So again, y1 equals to h of 2, which is going to equal to my original function, 2 times 2 to the negative 1/2, or 2 divided by 2 to the 1/2, okay? And this basically is of the same base, so I'm going to subtract this, and I'm going to just get 2 to the 1/2 power. So y1 is equal to the square root of 2. So then my equation is y minus the square root of 2 equal to negative 1 over the square root of 8 times x minus 2. That's my equation of the line. But notice again, what am I doing? I am taking the derivative, and then I am evaluating the derivative at the value that they want me to evaluate it at to get the slope. Then I'm evaluating the original function at the same value to get the y1 point, and then just plugging it into the point slope form. So this next thing we're looking at is, given the equation of a function, how might you determine the values at which the function has a horizontal tangent? So I'm going to go ahead and blow this up here. What does that mean, horizontal tangents? Horizontal tangents means, like I said earlier, means I have a 0 slope. So what would that mean is I take, if my function was f of x, then I want to find where f prime of x equals 0. So what x values would give me 0? Okay. So in the problem below, it says at what values of x will the function f of x equal to x to the third power plus x have a horizontal tangent? I have to take the derivative of this function. So f prime of x would equal to 3x squared plus 1. Then f prime of x equal to 0 is where I would find the x values that will give me a horizontal tangent. So I would take 3x squared plus 1 equal to 0. And if I solve for x, I will actually get I times the square root of 1/3 when you solve for it. So basically, this function does not have any real zeros for x because it never crosses the x-axis. If I were to take a look at this function on a graph, it would look something like this, where it basically has a y-intercept at 1, and it's like a car slowing down almost to a stop, but it's still moving, and then it starts to speed back up. Kind of like people here in San Antonio when they decide to drive, they get to a stop sign, but they never really do. They just kind of roll right through it, pretending that they are stopping, but they haven't. So for the next one here, I leave it for you guys to look at. If you think about this, I'm going to go ahead and do the exact same thing, but please pay attention to this part, interval of 0 to 2 pi. The reason why they give you intervals, especially with trig functions, is because trig functions are harmonic, meaning that they cycle over and over again. They don't stop. So they want you to evaluate this in between a certain range of numbers. So you're going to find a lot of values that will give you 0 in this situation, but they only want you to find the values that fit with inside 0 and 2 pi. You're not going to go beyond 2 pi. You're not going to go less than 0. That's it. Okay. So you should get f prime of 0 is going to equal to 1 plus cosine of theta. That's the first step. Sorry, I don't know why I said f prime of 0. It should be f prime of theta. And then what are you going to do? You're going to take f prime of theta and equal it to 0. So what does that mean? 1 plus cosine of the angle theta equals to 0. So solve for theta. Okay, what you should get is cosine of theta equals to -1, and then you're going to inverse cosine each side and get theta equal to certain radian values that should give you -1. There are many, okay, cosine values that will give you -1. They just repeat themselves. Just they only want the values that fit in between 0 and 2 pi. All right. So I hope that helps you out, guys. Again, to recap, looking at horizontal tangents, if I have a curve of a function, like say this parabola here, I want to find where the horizontal tangent is flat. That's a horizontal tangent right there. Okay? So I'm going to call this HT, horizontal tangent for short. Okay, this is where I have a 0 slope. Okay? All right. Hope that helps you out, guys.